Okay, so next question up. So we've been given these tables of values showing the relationship between x and y. So it wants us to plot first the relationship between x and y, and then it wants us to say which one shows a linear relationship. So let's go and plot this first one here. We will make up our axis first. So I plotted my y, now I'm just plotting my x across. Okay. So so I've got my axes there. So going on my x-axis first. So x-axis, y-axis. So my x, I'm going to -3, so -1, -2, -3. And I'm going down to -2, so -1, -2. So where they intersect is where I place my point, because that's the coordinate. All right, -2 and -1. -1 on my x-axis, and I'm going to 0, so that's where it intersects my x-axis. Where on our y-axis, so where x equals 0, we are intersecting the y-axis at 1. So that's my y-intercept. At x equals 1, y is equal to 2. Where x equals 2, my y equals 3. So again, just pulling these coordinates out of my table of values. So just coming back, this would look like -3, -2. So that's that coordinate. Okay, coming back to plotting these points, we've just got 3 on our x-axis to plot at 4 on our y. And again, we just join those points together, and that shows our linear equation. So let's go to part B of this question. So what it's asking for is to identify which are linear. So we can see that this one's linear because the line crosses all of those points. So the relationship between the x and y is the same for each point. So it's following the same rule. So linear relationship. So tick, that one has a linear relationship, and we've plotted that one up. All right, we're going to go on and look at the table of values for 2 now. Just get rid of all of this, get rid of our values, draw up our axis again, our x. Okay, let's get plotting. So -3, so -1, -2, -3. So -3 and up to 11. Might have to go by 2's here because I don't think I've got enough. So 2, 4, 6, 8, 10. So 11's going to be in the middle there. And where the 2 lines would intersect is where our point will be. Okay, so -2 and 6. So this is -2. We're going to go up 2, 4, 6. So remember, it's where those lines would intersect. -1 now is at 3. So 3 will be in the middle. So that will be our line there. Our coordinate there. Where we've got x is equal to 0, we're going up to 2. Now I can already tell that this isn't going to be linear because we haven't got the same relationship between our x and y at each point. So see how the distance between these two is changing, the distance between these two. So I'm sort of feeling that this isn't going to be linear. Sort of tapering off a little bit as we get closer to our x-axis. But let's keep plotting. So where x equals 1, going back up to 3 on my y-axis. Okay, so x equals 1 and up to 3 on my y-axis. Okay, so I can already see that I've gone from having a negative gradient up to a positive gradient, which means automatically that that's not going to be a linear equation. And if you actually look at the pattern itself, we go 11, 6, 3, 2, 3, 6, 11. So what's happening here is if I keep plotting, I'm going to have a bit of a pattern emerging, and it's going to be, again, that parabola or parabola shape. So it's got an x squared in there. And I know that because of the shape of it. But again, we're not concerned with that yet. So we're just going to say that's not a linear relationship. It's not a straight line that we're concerned with. So we're just going to leave that one there. Okay. Let's go to number 3. Get my pen out again. So again, as you can see, the x values, they've just decided to work with the -3 up to 3 and derive their y value from that. So let's go, x is equal to -3 and I'm going up to 10. Again, I'm going to go by 2's because I don't have enough intervals here. So 2, 4, 6, 8, 10. And again, where those lines intersect, where they cross over, that's where we're putting our coordinate. -2 up to 9. So again, remember that one's in the middle because we're counting up by 2's. -1 going up to 8. There will be lines intersecting there. Where my x is equal to 0, my y is equal to 7. So that's my y-intercept. So that's where my line crosses over my y-axis. That's important. Remember that. And all they've done is just plugged in where x equals 0. Okay, so where x is equal to 1, I'm coming up to 6. So 2, 4, 6 here, my next point. When my x is equal to 2, at 5 on my y-axis. And finally, where my x is equal to 3, I'm at 4. Okay, and it's simply joining those together again. Look at that beautiful line. We've only got these points plotted, but we can continue our line through. And you can see where each value would come in. And if we found the rule of this table of values, we could then determine the rest of these points as well. So as you can see, a negative gradient, going down, it's got a negative relationship. So for the increase in x values, so as the x values get larger, the y values get smaller. Negative relationship. Okay, so that one is definitely linear. All right, last but not least, let's go ahead and look at this one here, number 4. Don't forget, if you are feeling that you've got this, you're understanding it, fast forward, skip to the next video, your call. I am going to do this part of this question in this video, so potentially stay with it if you want to see that bit, or fast forward to it and skip over this part. Okay, let's quickly plot this last one. So -3 is at -28. Again, I haven't got enough points here, so I'm going to have to go up in, I think, 10, 15, 20, I'm going to go up in 5. So 5, 10, 15, 20, 25. 28 is going to be about there. So that's going to be that first point. -2 is at -9. So 5, 10. Oh, negatives. Negatives. What am I doing? I'm not even plotting them properly. It's -28, not +28. All right, let's start again. See, even teachers make mistakes. So 5, 10, 15, 20, 25. So I'm going to have to extend this line down. All right, so -3 is going to be down here at -28. 5, 10, so -2 is at -9. So about there. -1 is at -2, so about here. 0 is at -1, so about here. One is at 0. So 1's at 0, 1's there. 2 is at 7. So about here. And then 3 is at 26. So 5, 10, 15, 20, 25. So about here. So if I join these up, sort of like this. So it looks like that. So this isn't a parabola shape. This is a different one again. So again, it's not that nice straight line, although it may have it is heading in the same direction. It hasn't changed, down to a negative gradient. It's still not a linear relationship. We will come across that later on in our maths journey, but at the time being, not a linear relationship. Okay, let's get rid of this. Rightio. Start clean, start fresh. Don't forget you can put this on fast forward. Okay, this table, we've got a rule. It's given us a rule. It hasn't given us the full table of values. So you might remember substituting values into equations. So let's do this. So my rule is y equals 3x minus 5. Okay, 3x minus 5. Remember that this is our dependent value and our independent value. And all I'm going to do is go, I'm missing my y value here. So I'm going to go y equals, and then I want to know my y value. So y equals 3 times my x value in my table, which is 0. So I put my 0 in there, my place where my x would be, minus 5. So y equals, and we work through the sum. So 3 times 0, of course, is 0. And then we've got the minus 5. So y is equal to 0 minus 5, which of course 0 take 5 is going to be negative 5. So y is equal to negative 5. So that's negative 5 in there. So what that would mean is that where we've got our graph and x is equal to 0, where our y is negative 5. So that would be our y-intercept. So where x equals 0, that's our y-intercept. Okay, next one. Undo that. Okay, next value. So again, same formula, y equals 3x minus 5. That remains the same. So we want to find out our y value for here. And our new x value in the table is 1. So we're substituting in the 1 into our x. And we just work through and we solve it. So y equals 3 times 1, which is 3, minus 5. So y is equal to 3, take 5. So 3 take 5 is negative 2. So we just plug in a negative 2 into this spot. All right. And again, got one more spot to work out. So again, same rule, y equals 3x minus 5. So we want to find out our y because that's our dependent. So 3, and we take our x value of 3, plug it in there, take 5. So y is equal to 3 times 3, which is 9, take 5. So y is equal to 4. So then we go and we plug 4 in here. Alright, so then we can go and we can actually plot this and see the graph with the rule y equals 3x minus 5. So let's go ahead and quickly do that now. Get rid of all this. We'll draw up our axes. So got our x-axis across here. Take our y-axis. Whoa! Zoom out. Obviously hit a button I wasn't meant to. Y-axis down here. Alright, so let's plot. So where x is equal to negative 1, we've got our y is equal to negative 8. So negative 1 is here. So 1, 2, 3, 4, 5, 6, 7. Take this down one more. There we go. That's better. All right, so negative 1, I'm going to go down to negative 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's our intercept there. So that's negative 8. All right, so then where x is equal to 0, we've got negative 5. 1, 2, 3, 4, 5. All right. And then where x is equal to 1, we've got negative 2. 2, we're at 1, positive 1. And at 3, we're up at 4. So 1, 2, 3, 4. And then again, simply we just join those together, like so. And that is our line, that's our graph of y equals 3x, take 5. So we can see we've got a positive gradient and we've got a y-intercept of negative 5. Okay, and can we see that there's a correlation between this negative 5 and this negative 5? So let's just keep that in mind, that we've got a correlation between our intercept at negative 5 and our equation, which written in this format had this negative 5 at the end. All right, we're going to explore that a little bit in the next video.